Hello, everybody. My name is Michael. I'm with Data Nexus. I'll be hosting today on behalf of the Builders DAO. And today we have a recurring special guest, Thomas from the Builders DAO. He's going to go into the topic of substream triggers. And just keep that in mind that this is going to be recorded and posted on various social platforms. So if you have any concerns regarding that, keep that in mind. For right now, I'm just going to go ahead and kick it off to Thomas, and he's going to take it away.
All right. Thanks, Mike. Today we're going to be going over an interesting topic. The last, I believe, Builders, actually my first appearance here, we did a substream powered subgraph with pricing, and it was thrown into the chat that the graph node now supports substream triggers, as we call them. So traditionally, what you've always seen was a substream built, and you would essentially just pipe out the entity changes directly to the graph, to the subgraph, right? And then it's able to sync on the network, and it's a good solution. So this substream triggers kind of takes things to the next level and really opens up the door to have both the power of a subgraph and the power of a substream. So I'll be going over that with you guys today. So what is a substream? A substream, if you do not know, is a way to extract data from the blockchain, similar to the way a subgraph would, but in an extremely, extremely fast and highly scalable solution. So, things like the Uniswap v3, I believe substream is able to sync like almost 100 times faster than the subgraph version of that. So it's a very parallelized process, very, very powerful. It allows you to apply some custom transformations to that data so the block comes in, similar to the way a block would come into a subgraph. You could do some custom transformations to that. And then what a substream truly is at its core is it allows you to then pipe that data back out, right? It sends it to your place of choice, whether that be Postgres, whether that be to a file, or whether that be to a subgraph, right? Most of the times when we talk about substreams, we're talking about substream-powered subgraphs, but you really can pipe your data any which way you see. Now, so it's really just like a throughput method for your whatever your use case may be. So now, why would you want to use a substream over a subgraph? Obviously, the speed would be one of them, but based on my development time with substreams, you're kind of handcuffed. And if you're coming from a subgraph developer, you not handcuffed in a way, but you want to do things that you're just traditionally used to doing, such as accessing the entity store that you create, right? So a lot of times in subgraphs, what we do is we create an entity, we save it, we update values of that entity, and then when new things happen, we instantly could just pull it back up, right? You don't have that ability in a substream. You essentially have to create that in the substream. You have to recreate the store altogether in a substream, which really could hurt you because their store process, you cannot access the same store you're writing to, right? So if we created a store in a substream, you are not able to access that store within that same block. So if I wanted to know, if I'm setting like some type of interval or like clock time stamp in a store, in a subgraph, I could just say, give me whatever I last wrote, right? In this one, you only have access to write it, and then later on down the pipeline, you could access to read it, but I can't do any logic on the fly like that. So that's one use case where I feel as if if you're coming as a subgraph developer, you would definitely feel like you're handcuffed in a way. So now the next part of this is getting into the triggers. So remember what I said earlier is that as a substream, you have some type of throughput. You have the input of the block, and then you have an output of whatever custom transformations you do to it. And we've seen traditionally, I'll pull it up here in this substream that I'm going to use. We've seen the graph output. That's typically for the substream powered subgraph. So if we go into here, where do we got it? Modules. Actually, I don't even think there is one in this one. Let me get another one. So this is my chain link substream I wrote. If we come into here and we go down, we see something like this typically. There's this graph out module that's created in the subgraph, and it takes in all of your
Hey Thomas, do you mind expanding the screen a little bit?
Oh, yep.
Zoom in.
Yeah, well, let's make it a little bigger.
Yeah.
Good?
Thank you.
Yep. So the graph out module is what you typically see when you're looking at substream powered subgraphs, and it'll take in some type of message from the substream and will save it to this table structure, which essentially puts it into the table, the entity change table, which would then just go directly to the substream. I'm sorry, the subgraph, and admit them as if you did a .save on that entity, right? So that's the most traditional way of doing that. What we have the ability to do now with triggers is to take any of the modules, any of the map out modules of a substream, and we could use them as a source in your subgraph. So what I'm going to be doing today is using this Uniswap pricing substream that the BuildersDAO is kind of growing organically. And we want to use this as a solution for all pricing. And we're kind of building it out to that point. So if we take a look at the what's going on with this substream here, we have the block input. We're doing some stuff with Uniswap. We're doing some stuff with Chainlink. All right. So we have as of right now, two sources of truth in this substream. And then you can see there's map modules and store modules. What we're going to be looking at for triggers is these map modules. So a map module will take whatever data manipulation you've done and then pipe it out in some type of format, right? Whether it be to wherever your endpoint would end up. So each map module has an output of a protobuf definition, and we're going to be able to ingest that protobuf definition directly into our subgraph. So right here we have this final map Uniswap prices, and if we take a look at what that is outputting, I'll take the this big enough, Mike?
Yeah, that looks good.
Okay. Yeah. All right. So we're gonna come in here. I'm gonna grab the packed substream, and I'll run substream info on this. All right. Substreams info will show you all the necessary information about the modules in that subgraph. Substream. So I said we're going to be looking at the Uniswap one, which is going to be right here. Store Uniswap prices. It has input of map Uniswap prices, and it has an output type of proto Uniswap pricing V1 ERC20 price. So that's what we're going to be ingesting into our subgraph today. If we look at the structure of that, we could see in here, ERC20 price. So ERC20 price is again, a protobuf definition, and we're going to be able to stream anytime a pricing event occurs, right? So typically in a subgraph, I'll take a lending protocol as an example. They have some type of Oracle contract, and you may need to go to that Oracle contract, make an RPC call every single time you need a price update, which is extremely, extremely inefficient, right? But at the same time, you've already built this entire subgraph. You don't want to have to rebuild the entire thing in a substream, right? So what we could do here is that we will get notified based on the substream anytime an ERC20 price occurs, whether that be, as of right now, from Uniswap or from Chainlink, and then we could then do something with it as if it was an input of a block on the subgraph side. So this message is going to contain a token, which is address, name, symbol, decimals. It's going to contain a USD price, the block number it occurred in, the ordinal. This is another thing in Substreams that's pretty efficient, is that there's this ordinal you have access to that allows you to get the state to essentially pull up the ordering of all things that occur within a given block. This is different than your event log number. This is specifically like step by step. Hey, this happened at this specific point in the block. Let me now go reference that specific point. So having access to the ordinal is another great thing in a substream that you do not have access to in the subgraph. And you may be able to leverage that. Now, we also have this source where the update came from. So in a sense of like a lending protocol where they have multiple oracles that they use, you could actually derive which price this came from in the substream, all right? And also in the subgraph side, which I'll show you in a few. So we have right now just Chainlink and Uniswap, but we would like to expand this even further out into all type of oracles as we see fit, right? So maybe we'll have some other, like a curve pricing event, or any of your major oracles that a lending protocol typically uses for their pricing. So we'll know the source of the pricing event, which is huge, and then we'll have these most likely come in as a list. So in a given block, there could be numerous price changes. So they'll come in an array, and we'll loop over them. So let's jump into the actual code here. So I've pulled down this repo. If I pull it up real quick. So yeah, let me go to the graph node releases. All right, so with this release to the graph node, you'll see, hey, what's new? Substreams source as triggers a subgraph. This update significantly enhances subgraph functionality by enabling substreams to act as a source of triggers for running subgraph mappings. Developers can now directly run subgraph mappings on the data output from the substream, facilitating more integrated and efficient workflow. All right. So if we click on this commit here, we could see that an example was provided, right? So if we go into this example, you could pull down this package as a base, but it's really going to be the same thing for all your anytime you'd like to use Substream as a trigger in your subgraph. So we can see here in the subgraph manifest, we have this data source of kind Substream, the name for it, the network, which we'll be using something different today. You have the source package, and the source package is going to contain the module name. So in this case, they're referring to this SPK, this packed substream trigger filter, which has a module of near filter, and they're passing some params in. But in your case, when you do use this, you'll find the substream of choice that you'd like to map events into the subgraph with, and you'll get the packed version of that, and then just place it in your project directory. It could be anywhere in the root, wherever it is. And that's how you'll specify what module you want to take from the substream and where that pack substream is. All right, so you'll need those two locations. The mappings will be of graph entities, very similar to the way you do it now in the subgraph. You'll point it to the file, and then you'll point it to the handler of that. So typically when we have a handler, we're just ingesting a block. In this case, we're going to ingest the actual map out of the substrate module. Now, just a few notes to actually getting this set up, right? What you're going to need is you're going to need the protobuf definition of the map out module you'll be using from the substrate. So in this case, they have two here. In our case, we have this one pricing one that we were just looking at. All right. So in my project directory here, I have this protobuf folder. I have the Uniswap pricing proto, and it's exactly what we were just looking at. Let me make this a little bigger. Yeah, so we have you need the protobuf definitions for the substream in use. Now, I know some places you could go to like substream.dev. I don't think they actually allow you to, unless it's linked there, you wouldn't know the source code. So let's say I wanted to just use, this one. You have access to the SPKG, but you don't have the protobuf definitions here. Or actually, do we? Let's see. So it does give you some here, but depending on where you're going to get your source, or if you're going to just write your own substream for this, you'll need access to the protobuf definition. All right. So next, once we have the protobuf definition, we're going to have to actually create some code gen, all right, from that protobuf definition. So if we look at the package.json here, we have our typical graph build, graph code gen, which is going to just create, our generated schema types and such from our schema file. So right now I have just this really simple, just price event. And you will, so that'll do that code gen. Now there's this other script called proto-C. All right, so what that's going to do is going to take the protobuf definitions we have in this .proto folder, and it's going to generate this assembly .ts here. So this takes the protobuf definition and puts it into some type of assembly. It does code gen to create those protobuf definitions. If you're used to working with substreams, this is very similar to substream protogen, where it would take the protogen files in the substream and convert them to like a Rust type for use in your substream. So that's what you'll have here. You'll need this protobuf assembly script, AS. To generate that, you'll need proto-C installed on your machine. So those things should come in when you do, if you do pull down this project. But if you're not going to use this project as a base, just keep that in mind that you're going to have to code gen the protobuf definitions for use in the subgraph. And that's how you do that right here. So what that's doing is saying, hey, the output of this, store it in the source.pb folder, which we see here, and go into the proto folder, and any protos that are in there, I want you to parse and do some code gen on. All right, so I already executed that. I had a hard time doing this in Windows, so hopefully when I get some more time, I'll look into it. But it worked fine on a Mac, so that's just par for the course. So we can see here that the assembly, what this does is it creates this large thing of decoding this stuff. It will allow us access to it in our mapping.ts. So after you have that all set up, right, you need, again, your protobuf definitions. Here, you need to code gen them into this assembly.ts, and then in our mapping, we're going to have access to some of this stuff, right? So the way this works is that with the source substream that we've defined right here, you will have access to that message that's coming out, right? This ERC20 prices as we've seen earlier. So if we just jump back here real quick and go to the data flow here, we're again using this, which is it of that protobuf definition type. Okay, so everything that's coming out of this, we're going to be consuming. Now the way this comes in is it comes in as a set of bytes. Okay, so it's the input of this is always going to be the same. You could call it whatever you'd like in your handler, and it will be of type UN8 as an array. All right. So obviously we can't do anything with that. So we have to always first decode that. All right. So this bytes has a buffer that we're going to put into this assembly. Now, I'll take this out just so we can see this in practice here. So if you have assembly, it's going to give us two options here. So we're going to use the Uniswap pricing one, V1, and then you could see here we have access to all of those types, right? So we're going to do the ERC20 prices because that's what's coming in, and we're going to decode them. And to decode them, we're going to pass in the SS bytes buffer. Okay? So that's all you need to do. So now once you decode it, now you have that exact message that was being pumped out of the substream. So if I went to my screen here and did... Let me clear this. Let's run the substream. And I think this should work this way. Grab the name again. All right, let's see. So there's no events coming in at this point, but let's let that run and see if anything actually comes in. All right. So as that's going, so essentially what's happening here is that anytime we see an output from this, we would get a trigger in the subgraph side to access the data that's piped out, right? So again, the decoded part of this is important because you have to decode the bytes that came in into this protobuf structure, okay? The events that are coming in have items to it, right? It's a list of price changes. So I'm going to set that here. I'm going to check that it's not null, right? So if it is null, that means that we got no data back for that specific trigger. It should always be there, but this is just a good practice so that way you don't get jammed up in any way. So now what we could do is come down here and loop over those events, right? And once they come in, I have this in my schema here. I have some just really low level, just pricing event, right? That I'm going to create an entity for. And then from that, I'll create a new one. And now, if you see here, this pricing.events, we have access to everything that the event has, right? We have the block number, the ordinal, the price in USD, the source, as I said before. So again, a lot of the use cases in my head for this are for something where you're calling the RPC over and over and over and over again, where with this, you have a substream that has all of your events that are going to give a price. You don't have to rebuild this out into your subgraph. You could just import the price substream and do the logic within here. So let's say we only care about a specific one, a specific source. Like we only care about Uniswap prices. We have access to that source. We have access to the token. So let's say, as an example up here, we're setting the ID to token address, but we have access to that full token. So let's say you need some token metadata that usually you'd have to go to the RPC to get the symbol, the decimal, and all that. But you have access to that here as well. So if we wanted to create a new entity in the schema of token, we could do that here and save it anytime we see a new token come in, let's say. So the possibilities really start to become endless with this, and mixing and matching really becomes really, really powerful. With the power of substreams by itself, substreams are extremely powerful. But when you bring subgraphs into this, now you have access to everything you had access to before and the power of a substream. So I really can't wait to see what doors open with this. But yeah, you can see here we have access to that, right? So we have the name, decimals, addresses, symbols, the price, obviously, itself. So let me change this back to address. So for that, we could, again, access the price in USD. Let's say I wanted to set that. There you go. And then I could save that event, right? So what this could do is where you would typically go to the RPC to make the call to get the price, is that entire code could be replaced and there'll be no RPC calls happening here, right? So let's say for a given token, we need to update the USD balance, right? So you could do something like load the token that has the balance in it, token, balance, let's just say, and we could say, oh, okay, a price change occurred. Go get that token entity that has the total supply attached to it. Come in, grab the pricing, and then do a new, token balance, time the price, and then store that, save that entity right back on the fly. Where again, in the past, you would have to use the RPC, which we all know is like something that everyone tries to stay away from. So I feel like this is like a great use case to kind of showcase that and demo it and show you exactly what's happening and how you could use this. I'm sure now that this is out, there's going to be even more and more use cases for something like this. Like I could give another example where right now I'm developing a substream that has a lot of back and forth to the entity changes that occurred, such as like, hey, this bid expired. This bid, it has like these status changes. So right now, storing those status changes for 1,000 bids is really, really problematic and troublesome on the substream side. Because you have to create that store and then go back and reference that store to say, hey, what was the last status update to this bid? And it's really, really difficult to do that. So for this, I would replace that with just importing the maps of any time a bid status would change. And then in here, I could go pull that same bid, check it, and then do whatever logic I need to. Instead of having to call, again, like an RPC call to get whatever the current bid status is, I could just stream in those events. So just think of this as now a new type of data source that will stream in any data from the substream into your subgraph for use. And you can find any type of use case for that. So that's pretty much how it works. I don't want to push this up because I don't think the code. I was having a problem with the code this morning, so I don't want to show this on the hosted side. But it's going to be exactly as if you had a subgraph and you were doing these changes, right? It's just a different type of data source here, where typically we get the block. Now you have access to anything in that map. I don't know if anything pumped out here. So here we go. So let's go to the so here we go. Here's what would be coming into us. So at this block, 10 million, we would have in the subgraph side, we'd have a new price for Ether, right? And here's the USD price. And we know that the source was Uniswap for that price. And again, we have a new price for USDC, and we know that Uniswap is the source of that price. So this, again, is like a very contained use case and something that I think and the team at the BuildersDAO thinks is like really, really useful to be notified of any price change rather than having to just blindly go call the RPC to get it, right? So you may call the RPC and the price never even changed, and you just wasted some processing time. With this, you're going to get notified of every time a price change happens. And thanks to James at the BuildersDAO for putting this base one together. He's been working on this, and we've been brainstorming a lot of ideas with this. To use this now in practice, we're really excited to jump in on that, right? Again, there's a use case where we're making RPC calls to a lending protocol oracle, which is just underneath the hood is going to any of these, it's going to Uniswap, it's going to a Chainlink, it's going to Curve, it's going to all these other, on-chain price sources and just returning the price to you from them. So rather than having to go and do it blindly, now you're going to get notified anytime the price changes, and you could remove all that RPC code that is probably slowing down your subgraph tremendously. And yeah, you can see here there's even more coming in. These are like really early blocks, so I'm sure we're not going to get anything other than these two, but here we go. Here's a new token that would come in. So again, at this block in your subgraph, you're going to get the price update for this. And if you're dealing with this token, rather than go call it blindly when some other event occurs, right? You can now just go in, get this as a source in your subgraph, and then do any changes when you know the price changed, rather than having to go in blindly. So I'm sure this, again, is going to open up the door for many, many, many more use cases. And I hope that I see that come to fruition. So, Mike, that's really all I got today on showcasing this.
Awesome, man.
I'm really excited for this. So,
if you look in the chat, it looks like there's a question here.
Let's see. I got to get into the habit of keeping this thing open here.
No worries. I'll inform you if it's.
Oh, okay. Here we go. Okay. So Paco couldn't make it, unfortunately, and he's the one that got this all started. Got us on this. Got us into this. So I hope I did it some justice today, Paco. James, plenty of use cases in future office hours related triggers in the future. I imagine a bit of game changing. I think what you're alluding to is that Substreams could potentially do the heavy lifting data transformation, utilizing the benefits of Substreams and deferring subgraph-specific logic just to the subgraph. For example, subgraph, store, read, and writes. Yeah, absolutely. So one powerful thing on the subgraph side is the subgraph store, read, and writes, which doesn't exist on the Substream side. And then on the Substream side, you have the speed, you have the access to more data, you have a lot of different types of data transformation that could occur. So you could leverage the Substream side for your events, just do all your logic on the Substream side, and then just eventually say, hey, I want to notify my subgraph of this and pipe that out. So it really gives you a lot of flexibility, and it really takes things to the next level here as far as Substream and subgraph integration goes. Before, like I said, most use cases always showed off the subgraph, the graph out, and just piping out entity changes. Now, I feel like it shouldn't even be the case anymore. You should just use the substream or just create all the mapping of stuff that you like, pipe them into the subgraph, and then just use the subgraph store to your advantage, right? So a lot of times it's typical in any subgraph development to go access the entity that's already created and use those values. So you're essentially using you have like this virtual database available to you, where on the Substream side you don't have access to that. You just have access to whatever's in the store that you create, which the store on the subgraph side kind of happens organically as you're saving these entity changes to your subgraph. You're creating a store in itself, and on the Substream side, you have to create it from scratch. You have to do it, and it doesn't care about what you piped out. If you didn't specify that you're going to save it to the store, it disappears. Because again, a Substream at its core is just a throughput, a very, very fast throughput of the data on the chain, then the data manipulation, and then output of that data. So the store helps you on the Substream side to access these things and save them if you need it for your logic. But if you feel as if like it's just, hey, I'm saving these changes anyway in my subgraph, these are entities that I need to repurpose, then there's no reason to even use the Substream store. You just have super, super fast throughput with maybe some data manipulation like we see here, and you're good to go. So thank you for the question, James.
Nice.
Anything else? Anyone else got any questions? Don't be shy. All right.
We'll take that silence.
We got a Pinex guy asking questions. Excellent presentation. Yeah, great. Thank you, pal. Thank you. I think you're gonna complain about my mic again, but I think we got that sorted.
You did great.
Yeah, and maybe next time we have something that could get pushed up. That would be cool, and actually see the changes on the subgraph side. But unfortunately, I was having some environment problems this morning, so
no worries. Yeah, but that'd be great. Even doing that for a future talk, even if you run into any issues, like walking people, like showing the motions of getting through those kind of stops and barriers, and that's always helpful.
Really, it's because I'm a diehard Windows guy, so I just shoot myself in the foot with that. But I'm not willing to give it up yet.
I understand. I'm in the same boat. All right. Well, that's all we have for today. I want to thank Thomas again for his presentation. Once again, you knocked it out of the park. If you have any questions, if you're viewing this at a later date, go ahead and I'm assuming, Thomas, you're okay with people reaching out to you. Easiest way via Discord, I imagine.
Yeah, Discord. Just come into the BuildersDAO chat, and I'm always available there. So,
awesome. Okay, good. Well, with that, I'm going to go ahead and end this off for today, and we will see you all next week.
All right, great. Thanks, guys.